Hi, good evening. My name is Joel John Jobinse, and I'm here to explain experiment 3 of neural networks, which is the XOR model. Our aim is to implement a perceptron for classification using Python using non-linearly separable data. And our input data for the XOR is we have the truth table, which is 00 returns 0, 01 returns 1, 10 returns 1, and 11 returns 0. And so the shape of the X matrix, that is of the inputs, these that are 00, 01, 10, and 11, is 2, that is 2 inputs, and 4 total rows. And the Y shape, that is the output, is of one output for 4 different inputs. And so that is 1 cross 4. And this is the Python code where we import libraries such as NumPy and Pandas and IO and Matplotlib. And we define the arrays for the inputs and outputs, X and Y, and the number of input neurons, number of output neurons, and number of hidden um hidden layers. And we define M value and the learning rate, which is zero point 0.1. And we define the weight matrices, which are w1 and w2, which is taken at random first. We have two neurons in the input layer, two neurons in the hidden layer, and one neuron in the output layer. And the activation function we use is sigmoid. Forward propagation computes prediction. So this is our sigmoid function we define in the code. And forward propagation, z1 equal to w1 dot x. These are the formulas that we use. A1 equal to sigmoid of z1, z2 equal to w2 dot a1, a2 equal to sigmoid of z2, and output. And we define the forward propagation code using these formulas. And the loss function we use is binary cross entropy, which measures the prediction error and decreases over training. And back propagation, it computes gradients, and we use these values that we calculate from the back propagation to update the weights and reiterate until we get the accurate values. And we have some certain formulas for that, which is implemented into the code as well. And training loop, we loop for over 10,000 iterations to get maximum accuracy. And forward propagation compute loss, back propagation update weights, and store loss for plotting. This is the cycle that we use. So we have 10,000 iterations as per the code, and we calculate the loss. We store the loss into to plot the graph, and we keep updating weights based on this. And prediction, so after the training, model predicts XOR. So 10 returns 1, 11 returns 0, 01 returns 1, and 00 returns 0. And we use a certain function for predicting this, and we test this function using some certain test values. And so our summary is: a working neural network that learns XR, shows full forward plus backward propagation, implements gradient descent manually, demonstrates how simple a neural network learns nonlinear functions. Thank you.